Hello, friends. It's your guy, it's your dude, it's your man, the knick-knack, cardiac attack, patty whack, Raptis, here to show you the way that we do data-driven search bar so you can buy a sports car. You can find the repository link in the video description. Like, subscribe, and share with your friends. Today we're going to be starting with a very common problem. We have a list of data and we want to be able to effectively search through it. This seems fairly straightforward. It's something that people are doing every day. So we're going to build this app that lets us search through New York City high schools. It loads data from the web, syncs it to CoreData, and then does a search using a combination of NSPredicate request and client-side filtering and sorting like native Swift. So it's even going to highlight the portions of the text that match your search by making them bold. I've placed a system design diagram of what we are building on the screen here. I'm not going to go through it node by node, but please use it as a reference if you want to see a high-level snapshot of the system. So the data comes from a common endpoint, this list of New York City high schools. I'll go to it really quick. Here it is. Importantly, each school has a DBN. That's kind of a unique identifier, and a school name. That's pretty much all we're going to be using. So you can find that endpoint in the final project or in the video description. So very briefly, what this project is going to do is going to retrieve the JSON data from the internet. It's going to then decode the JSON data and turn it into models. Then we're going to be synchronizing those models into a CoreData database. The search terms are going to get tokenized for faster searching. So in this diagram, there's kind of two entry points to CoreData, either when the user is changing their text or when the app first fires up. It's important to notice that you don't necessarily need a network connection if you had previously pulled the data. So this is a web-safe application. So I'm going to go ahead and kill these things and start the project. And please follow along for optimal learning. So I'm just going File, New Project. This is going to be an iOS project and an app. I'm going to name this High School Hunter. And I'm not going to use CoreData. I'm going to manually add that later, and I'm not going to add tests. So I'm just going to go ahead and create the first file, which is going to be application controller. So I went File, New File. This is going to be a Swift file, not a SwiftUI view. So here this is, application controller. And we're going to be using MVVM architecture here, model view, view model. This, I guess, is going to be the highest level object at the view model layer. I'm not going to use observable object. I don't want this to cause updates. This is essentially going to be the storehouse for our network and database managers. So I'm going to say class application controller, and I'll just leave it empty for now. And I'm going to drag this up to the top. Now I'm going to create a group for the networking layer. So I'm going to right click on the root level directory and say new group. And I'm going to name this open bracket network close bracket, and I'll just do the brackets for alphabetical order reasons. Then I'm going to right click on that network group and say new file. This is going to be a Swift file, and I'm going to create network manager, and this is just going to be a class network manager. Now I'm going to create a database layer, so I'm going to right click on this root level directory again, make another new group. This one is going to be database, and I'm going to right click on the database layer, new file, Swift file. This is going to be database manager, and again this will be a class database manager. And as I said, the application controller is going to house these, so I'm just going to have one of each. So let network manager equal a network manager, and let database manager equal a database manager. Alrighty, now I'm going to make another group for more UI related stuff. So I'm going to right click on that root level directory, another new group. This one will be open bracket UI, close bracket. And within here, I'm going to right click, make a new file. It's going to be a Swift file, and I'm just going to name it view model. This view model, I do want to be an observable object. I want this to drive UI to cause updates. So I'm going to say class view model, and that is going to conform to observable object. Now I want the view model to have a reference to the application controller. So I'm going to say let app be an application controller, and when I init, I want to feed it an app of type application controller, and then say self.app equals app. So we'll just assign that. Now I'm going to right click on this UI layer again. I'm going to say new file. This time I'm going to pick SwiftUI view, and this is going to be for our school searches. So I'm just going to call this school search view. And now I'm immediately going to get rid of the previews. They're not going to do us any good in this project. They don't work right with CoreData. So school search view wants a observed object reference to the view model. So I'm going to say observed object var view model of type view model. And I want to add an init here, so I'm just going to say init taking a view model of type view model, and that's just going to be self.viewModel equals view model. And for the body, I'd like to just have something different that I can see, so I'm going to change hello world into high school hunter. And where do I want view model to be created? In my architecture, I would like it to be created lazily from application controller. So I'm going to go ahead and do that. I'm going to say lazy var view model, and that is going to be a view model. App is just going to be us. And since this is lazy, we have to put open parenthesis, close parenthesis at the end. So let's link it up. I'm going to go to high school hunter app, and I would like to add a copy of my application controller. So I'm just going to say let app equal application controller. And this content view I'm going to get rid of. I'm going to replace that with school search view. And the view model is going to be app.viewModel. And then I can just get rid of content view. We don't need that anymore. And I've targeted iPhone 14 Pro Max. I'm just going to build and run to make sure we get that school search view, high school hunter. We've got it. So now I'm going to go into the network layer and I'm going to create an object for our JSON parsing. I'm going to right click on network layer and say new file. This is going to be a Swift file. And I want to distinguish between where these models come from. So this is a networking one. I'm going to put NW in front of it. So I'm going to call this an NW school. And this can be a struct. I'm going to say struct NW school. And that is going to be decodable. And I'm not going to sift through the JSON with you, but two of the things from the JSON is dbn, which is a string, and another one is school underscore name, which is a string. That's pretty much it for the network model. On Network Manager, I'm going to add a function to fetch the schools. So I'm going to say func fetch schools. This is going to be asynchronous and a function that throws, and it's going to return an array of those NW schools. So I want to say let URL string equals, and then I'm going to copy and paste this string. Boom. And I would like to make sure I can get a URL from that. So I'm going to say guard let URL equals URL from the string, URL string. Else I'm going to throw a URL error of type bad URL. And the magic of async await, I can just say let data don't care equals try await URL session shared data from that URL, and then I can decode that. I can say let schools equal try JSON decoder dot decode an array of NW school dot self from the data, and I can just return schools. Beautiful. So now we've got that. I'd love to give it a call and make sure it works. So I'm going to jump into view model, and what I'm going to do is introduce a concept of an initialization sequence. And the purpose of this initialization sequence is going to be to kind of juggle stuff back and forth between the network manager and the database manager. For now, it's just going to be the network manager. So let's go ahead and do it. I'm going to say func initialization sequence, and I'm going to call that as soon as view model initializes, initialization sequence. And this is going to be some asynchronous stuff, so I'm going to put it inside of a task. And I want to get an array of those NW schools. And I want this to still have an empty array even if the network manager fails for one reason or another. So I'm going to say var NW schools is an empty array of NW school. And then I want to do a do catch, and in the do I want to say NW schools equals try await app.networkmanager.fetchSchools. For the catch, I would love to see this error, so I'm going to say catch that error. And in this case, I'm going to print error network manager fetch schools, and then I'll just put the localized description, so error.localized description. Then once we've got the schools, I just want to print out that array to make sure something came back. So schools will be NW schools. Let's see if that prints something out. Looks like it did. So there's a whole mess of data here. Groovy. Oakley dokley. So we've got the networking version of the model. We're gonna have 3 in this app: the networking version, the database version, and then the UI version. Let's go ahead now and make the UI version. So I'm gonna right click in this UI group, and I'm gonna say new file. This is gonna be a Swift file, and I'm gonna name this UI school. It's going to be almost the same thing as the networking version. I'm just going to paste it in there. It has 2 initializers, one with a DBN and school name, and one with the networking model. And that just calls the other init with the DBN and school name. This is going to be used for rendering UI, and there's going to be more than one of them. So there's going to be a for each that's going to wrap around an array of these things, and for that reason I'm going to make an extension for UI school where it is identifiable. DBN is a UUID, so I'm just going to say var ID, have that be a string, and that's going to return DBN. So now I'm going to go to the view model, and I want a published list of schools. When this updates, that means the views that have this as an observed object are going to redraw. So I'm going to say published var schools, and I'm going to start this as an empty array of UI school. And at the end of initialization sequence, instead of printing schools, I want to convert those NW schools into UI schools. So I'm going to say let UI schools equals NW schools dot map, and this is going to make a UI school that takes the NW school as an argument from this map function as its own argument. So cache 0. And I want to trigger a UI update. We might be on a background thread, so we've got to jump to the main actor. I'm going to say await main actor.run, and then I'll say self.schools equals UI schools. Now I'm going to jump to school search view, and I want to add a cell that can render one of these schools just with its name, and I'm just going to paste in this view here, school cell. So it is essentially an H stack with the text inside of it. It's just going to be whatever text we put in, which for us will be the school's name, and it's got some background styling and some padding just to make it look better. You can type that in or copy it from the final project. I recommend that you type it in if you're not great with SwiftUI already, with the UI part of it. So to get this text from the school, we should really leverage the view model. So I'm going to go back to the view model, And viewModel serves as an interpreter, as a formatter for things of this nature. So we're going to have the viewModel format our school model for us to spit us back a name. And eventually we're going to really be using that relationship to do the bold text highlighting. But for now, it's just going to be functioning as a dumb terminal. So I'm going to say func name for school, taking a UI school, returning a string, and I'm just going to return the school's school name. So let's tie it together. Let's go back to school search view. And for this body, we want a for each inside of a list that renders these school cells. And there's a few other little finicky things that need to be fixed with this too. So for body, I'm also just pasting in what I've arrived at for the body. And I recommend that you, again, type this in if you're not completely comfortable with all of these concepts. One thing I'll explain really quick is that I put a large spacer at the bottom of this list. That is so the keyboard doesn't block the bottom school. We can scroll and see what's at the bottom of our list. The reason I'm using a list is to get that UI table view recycling behavior / not loading things not on the screen. If we have 1,000 cells showing up and it's not in a list, it's going to lag. Using this list is going to get rid of that lag. Using the list comes with a price. All these list row insets and list row separators, we've got to override them by default. Apple has picked bad values for us. So I'm going to go ahead and run and show you what it looks like. And I do believe it looks pretty good. So this is just all of the schools, every single one of them. I think it's somewhere in the ballpark of 400. It might not always be the same number. They certainly seem to change order from call to call. But there you go. So list of schools from the network being converted into a UI model and that being used to render. Now what about the database? Okie dokie. Data, baby data. Let's go. So I'm gonna expand this database group, and within the database group, I'm going to right click and say new file. Here's where it gets different. Now I'm gonna filter by the word data, and I'm gonna select data model. And this, you can see up here, is for CoreData. And I'm going to click next. No original names here. I'm just going to name it database and create it. And in this version of Xcode, to add an entity, the button is down here. So I'm going to add an entity. And in this version of Xcode, it creates an entity that can be renamed. So I'm going to rename this to DB School. And I just like to add the same attributes here that we have everywhere else. So I'm going to go into attributes and click add items. And this is going to be an attribute named dbn. The type is going to be string. Then way over here in the inspector, I'm going to uncheck optional, which only matters for crashing or not crashing. Since this is an old school style object, we're still going to have to unwrap that. And I'm going to create our one other attribute, which is school underscore name. And this again is a string. And I'm again going to make this not optional. Now this will automatically generate a class. You might have to close Xcode and clean it and rerun it and do that more than once before it recognizes the class. But what we just did is going to create a class named dbSchool that we can use within our project. So I'm going to go to Database Manager, and now it's time to hook up CoreData. So I'm going to import CoreData, and I'm going to add a persistence container. So I'm going to say let container be an NSPredicate container, and then I'm going to add a required init, and in this init I'm going to say container equals an NSPredicate container with the name of database. And I would like to make a function to load the persistent stores, but I want to make an asynchronous version of it. So I'm going to be using that checked continuation. So I'll say func load persistent stores async. And here I'm going to await with checked continuation. And this is going to take a continuation in. And here I want to do container.load persistent stores. And we'll get a description and possibly an error here. But at the end of this, or in the completion, I just want to say continuation.resume. We've made an asynchronous wrapper for load persistent stores. So from the Apple documentation, once the persistent container has been initialized, you need to execute load persistent stores to instruct the container to load the persistent stores and complete the creation of the CoreData stack. So this is just a necessary step. Now I'm going to add a function to fetch schools, assuming that we had schools in the database. So I'm going to say func fetch schools, and these are all going to be async throwing. And this one is going to return an array of dbSchool. Remember, if that doesn't exist for you, you may have to clean the project. You may have to fiddle around with it. So here I'm going to grab the context from the container. So I'm going to say let context equals container.viewContext. And I'm just going to start with an empty result. So I'm going to say var result equals an empty array of dbSchool. And at the end, I'm just going to return that. Now, I am going to do all of my database operations on a perform block. And this method encapsulates an auto-release pool and call to process pending changes. And essentially it's just going to execute that work on the CoreData queue. I found that if I don't do this, it occasionally crashes. So I'm going to say try await context.perform, and in here I'm going to grab a fetch request from that dbSchool model. So I'm just going to say let fetch request equals dbSchool dot fetch request, and now I'm going to say result equals try context dot fetch, and it's just going to be this fetch request. Now I want to add another function that will update the data from the network data. So I'm going to make another function update data, and this is going to take an array of NW schools of type NW school, and this again is going to be an async thrower, and again I'm going to say let context equals container dot view context, and again I'm going to try await context dot perform. And what I want to do is just loop through all of these schools, create a DB school, and then at the end of all of that, save the context. So I'm going to say for NW school in NW schools, let DB school equals a DB school, taking this context as an argument, context, and then DB school dot dbn is going to be set equal to NW school dot dbn, and DB school dot school name is going to be set to NW school dot school name. Then I've just got to save the context. So I'm going to say try context dot save. Oakley dokley. Now let's jump into UI school and add another initializer that takes a DB school. So I'm going to go below the NW school initializer, let's make another init with DB school of type DB school, and this is just going to call self.init, and it's going to be the dbn school name flavor. Dbn is going to be db school dot dbn nil coalescing to an empty string. School name is going to be db school dot school name nil coalescing to an empty string. Simple as that. So let's get our initialization sequence to the point where we load from the database. So I'm going to go back to view model, and at the very beginning of the initialization sequence, what I want to do is load those persistent stores. So I'm going to say await app.databaseManager.load persistent stores. And then after the network fetch, if we have some new data, in other words, the NW schools has something in it, account greater than 0, let's replace what's in our database with that new data. So if NW schools.count is greater than 0, and this is another place where I really want to trap that error, so I'm going to do a do catch, I guess let error. But in this do, I'm going to say try await app.databaseManager.update data with these NW schools. And for the error, I want to print error database manager update data, and just print that error's localized description. All right, now let's load the DB schools from the database. So before the step where we're getting the UI schools, I now want to say var DB schools and start that as an empty array of DB school. And then again with the do catch, so do, and then catch let error, And for this do, I'm going to say db schools equals try await app.databasemanager.fetch schools. And for the error, I again want to print. So I want to print error database manager fetch schools and get the error's localized description. And now UI schools, instead of coming from NW schools, can come from DB schools. So I'm going to get rid of this and say let UI schools equals DB schools dot map, and it's going to be UI school taking a DB school of cache 0. Cool. So we should be able to run it and see it working. Now, it's not going to look any different, but these now come from the database. And we're going to have a problem at this point. So if I take these UI schools and sort them, so I just add a little dot sorted to the end of this with like LHS, RHS, and have that be LHS.schoolName less than RHS.schoolName. And I'll run it again. We're going to start seeing duplicates. So I see 2A Philip Randolph. If I run it a third time, we're going to have 3 duplicates of everything. So every time it's inserting new entities into the database. CoreData doesn't know that DBN is our UUID. CoreData has its own identifier, and we can't change it. So what we're going to do is purge the database every time we update the data. So I'm going to go back into Database Manager, and inside of this perform block, before that loop, I want to make a batch delete request. So I'm going to say let fetch request equal an NS fetch request of type NS fetch request result with an entity name of DB school, and then I want to say let batch delete request equals NS batch delete request taking a fetch request, our fetch request, and then say try context dot execute batch delete request. So every time we update the data, we're going to get a whole new database. For this use case, that is a good way to do it. So as you can see, we've got just one of everything now. So I'm going to go and get rid of that sort from viewModel. Don't need it anymore. Coolness. Now it's time to start moving towards our goal of searchability. And I'm going to do something weird, which is to start with the intent function on the viewModel. So I'm going to make a func called update search text intent. And this is going to take some search text of type string. And I'm just going to have a private var, private set var search text. I'm going to just start it at the word school. And update search text is for now just going to be self.search text equals search text. And now I want to use this. So I'm going to go into school search view. And I'm going to make a state var for search text. So I'm going to say state private var search text, and this is going to be of type string. And on init, I'm going to set search text or self.search text to view models search text. For the UI to render the search cell, I'm again going to paste this in. I'm going to make sure I get it all on screen at once. But it's essentially a text field that binds to this search text with a lot of whatever I could do to get rid of auto correction and auto capitalization. It doesn't get rid of all of it. In the current version of iOS, there's still quite a few things you can't turn off. Apple, if you're listening, would like to be able to disable the recommendations and the auto selecting where it turns the text red and shows little bubbles and things. Yeah, there's just no little hook to turn those off. So then for this search cell, I'm just going to add it to the top of this VStack before the list. So I'm just going to say search cell. And then down at the bottom, I'm going to add an on change. So dot on change of search text. What I want to do is view model dot update search text intent, taking cache 0. So that's just going to call that function whenever search text changes. I'm going to run it just so we can take a look at the search bar. There it is. We can type in it, and it's going to call that function. Okie dokie. We've got the search bar. Let's put a brain in it. So I'm going to go back to Database Manager. And this is going to be the beginning of one heck of a gnarly sequence. So below fetch schools, I'm going to make a new function called search schools. And this is going to be with search words, and that's going to be an array of strings. And of course, this is going to be an async thrower, so async throws, and returning an array of dbSchool. And for now, I really just want to make this mirror fetch schools, except maybe shuffle the schools so we can see some changes as we type. So I'm just going to say var result equals try await fetch schools, and then result dot shuffle, and then return result. Alright, now it's time to add a new layer to our application. So I'm going to right click on the root level directory and say new group. This is going to be open bracket search close bracket. And the first thing I'm going to make for search is a tokenizer. So on search, I'm going to right click and say new file, select Swift file, and I'm going to say tokenizer. And this I'm just going to paste in. Tokenizer has a function tokenize, takes a string, chops it up by spaces, gets rid of anything blank or empty, and gives you back lowercase words. So all of the searching is going to be done by comparing lowercase words with other lowercase words. That'll speed it up. Alright, so let's pipeline this search into our flow. So I'm going to go back to View Model, and where we have Update Search Text Intent, I want to make a similar asynchronous update search function, but we'll make this one private and we'll only call it from View Model itself. So I'm going to say private func update search text async, and this is going to take search text as an argument just like the other one, but it's going to be asynchronous, and it's going to start just the same way. Self.searchText equals search text. Now what I'm going to do is go up to this initialization sequence, and everything from DB schools down I'm going to cut. So from var DB school equals DB school array all the way down to that assignment of my own schools. I'm going to cut that out, and I'm going to move it into update search text async. And now what I'm going to do is on initialization sequence, after we have done our network fetch, essentially as the last step, I'm going to say await update search text async, and I'm just going to pass in our search text. Then on update search text intent, I'm going to get rid of the body and replace it with an asynchronous task, and here I'm going to say await update search text async, passing in search text. Now a very important change, instead of doing fetch schools, now we want to do search schools, but we need those words to search with. So up here next to search text, I'm going to make another private set var, private set var search words, and this is going to be an array of strings. And when we set search text, I'm going to set self.searchWords to tokenizer.tokenize search text. And now in place of fetch schools, right here where I'm selecting, I'm going to do search schools. I'm going to hit dot search schools, and the search words are going to be search words. And now this error is not pertaining to fetch schools, it is pertaining to search schools. So we should be able to run and see those results change as we type. So there's some schools, and then I'm going to start typing. So this is just shuffling the whole list every time we type. But it looks like the functions are linked up correctly. If you didn't see anything change, you did something wrong or different. Awesome burgers. So now we want to load up our database entities with search terms. The fastest way to do this with NSPredicates that can scream through the data ends up being to create just 16 attributes for 16 search terms. It could be even more, but 16 is a good computery number. So I'm going to go to database and I'm going to select my entity, DB school, and I'm just going to add all these search term 00 through search term 15. These are all going to be strings. They're all going to stay optional. So there's search term 00, search term 01, string, search term 02, string, search term 03, string, search term 04, string, search term 05, string, search term 06, string, search term 07, string, search term 08, string, search term 09, string, search term 10, string, search term 11, string, search term 12, string, search term 13, string, search term 14, string, and finally search term 15 as a string. And you can click off and back onto the entity and it will resort. So now I'm going to jump back into Database Manager. Okay. Haters want us to stop, but we just keep going. So let's get those search terms injected. Whenever we're adding a new DB school to our database or to our managed context to save into our database, we want to go through and potentially add all 16 of those terms, however many we can get. So let's see how many we can get, and we can use our tokenizer. We're just going to use the name, so we're essentially going to be searching the name of the school. So let search terms equals tokenizer.tokenize, and it's going to be nwschool.schoolname. And now I'm just going to make a bunch of if statements of this format. So if search terms.count is greater than 0, then db school dot search term 00 equals search terms 0. The other 15 are going to be the same thing, incremented by 1. So that will take care of assigning our search terms and ultimately saving them into the database. Now we want to be able to fetch something out based on those search terms. And what I've found is that it's good to do it for one word at a time. So I'm going to make a function that searches all 16 of those terms against one word. So I'm going to say func build search results for word. That's going to be a string. This is going to be in a context, and that's an NS managed object context. This is going to be an asyncer and a thrower, and ultimately returning an array of DB school. And just to make the compiler not complain, I'm just going to say var result equals an array of DB school, and then at the end return result. So what we need to do is take 16 predicates and combine them into a compound predicate. This is the fastest way to do this lookup. So I'm going to say let predicate 0, 0 equal an NSPredicate with format and args. And this is going to be search term 0, 0 contains %ampersand. The argument here will be word. Then I'm going to build the other 15 predicates, all very similar. Now let's turn those into a compound OR predicate. We want this to return true if any of those predicates is true. So let compound predicate be an NS compound OR predicate with subpredicates. And this is going to take an array of predicates. This is going to be predicate 0, 0, predicate 0, 1, predicate 0, 2, predicate 0, 3, predicate 0, 4, predicate 0, 5, predicate 0, 6, predicate 0, 7, predicate 0, 8, predicate 0, 9, predicate 1, 0, predicate 1, 1, predicate 1, 2, predicate 1, 3, predicate 1, 4, and predicate 1, 5. All right, now let's make a fetch request. So I'm going to say let fetch request equals db school dot fetch request, and I'm just going to say fetch request dot predicate equals compound predicate. And let's use this results. So I'm going to do what I always do to prevent these crashes and do this in a perform on the context. So I'm going to say try await context.perform, and in here I'm simply going to say result equals try context.fetch with this fetch request. Rockin' and a rollin', always running and never strolling. So we've done a lot. Let's try to get some kind of a confirmation that what we did actually works. So I'm going to change search schools to actually use that build search results for word function. And what we have now, by default, fetching schools, I'm going to have this be what happens when we have no search words. So by default, if we're not searching with any words, it's going to return everything. So I'm going to say guard search words dot count is greater than 0, else it's going to do fetch schools. And I'm going to get rid of the shuffle. That was just a test. So in the default case, I would like to say let result equals try wait build search results for, and I'm just going to pick out the first word from our search words. So search words 0. In context, we're gonna need that view context. So I'm just gonna make a variable for it. Let context equal container.viewContext. So that will be the context. And then just simply return result. I'll change this other one into a let. Alright, I'm gonna run it, and whatever we see in that list should be within the first word of our search terms. So these look like they all have the word school in them. If I pick something more complex like Frank, and see all of these names have the word Frank within them. If I do Bronx, everything has Bronx within it. So it works great for one word. Okie dokie. We know how to compute, but do we know how to love? Let's prove that we don't. So now that we've pushed NSPredicate to its breaking point, let's push it even farther. And I'm going to show you a diagram. And this illustrates a theoretical search grid. So the user typed in app and SA. That's a list of search words. And we can see the result lists for both of those individual search words. The final result of what we would want to pull out from the database is highlighted in green. In other words, something where both of those words match and not just one of them. For example, snapper matches app, but there's nothing in SA that matches snapper. So we're ANDing all of our search terms together, and what that means is that we want to take all of those gigantic OR predicates, and we want to make an even bigger predicate that ANDs all of those together for all of the words. And that is going to be the limit of what we can do with NSPredicate. So let's go ahead and do it. It's now going to be build search result for words, and this is going to be an array of strings. And now I'm going to loop through each word. So for word in words, I'm going to take everything up to this compound predicate and put it in that loop. And now I want to build a list of all of these OR predicates. So I'm going to say var and predicate list, and this is going to be an array of NSPredicate. Now I'm going to rename compound predicate to just be OR predicate, and then I'm going to say and predicate list dot append OR predicate. And then after all that looping, I'm going to say let final predicate equals an NS compound predicate. And this is going to be an AND predicate with subpredicates. And we'll just pass in AND predicate list. And now the fetch request predicate is going to be final predicate. So I'm going to change this call to take words, and instead of search word 0, it's going to be all of the search words. So I'm going to go ahead and run. And for school, it's pretty difficult to tell if we have a good match or not. So I'm going to search for Frank. And we can see 4 results for Frank. And there's only one Frank Sinatra, so if I type Frank Sin, that just pulls up Frank Sinatra. So it has anded all of these things together. Now there's a problem though, so if I say Frank Sin, Frank, that still matches Frank Sinatra School of the Arts. And if I type Frank School, that matches all four of these results, but it should really only match Frank Sinatra School of the Arts High School, since that has the word school in it twice and the word Frank in it once. Cool. So I'm going to show you a quick diagram of this shared word problem. And it gets worse in some cases when we're trying to use natural language to just spell out the actual name of the item we're trying to search for. Some titles have the same word in them twice. We can't share search terms in this way. So we're going to have to take a lot of steps to get around this. And we cannot do it with CoreData, or we are not going to do it with CoreData. The predicates that it would produce would be absurdly ridiculous. So let's do it ourselves. And I'm going to go ahead and introduce a new thing called item with search terms. I'm going to go to search and I'm going to make a new file. This is going to be a Swift file. I'm just going to call it item with search terms. And I'm going generic. So everything else that I add for searching and sorting is going to work on generic data. It's not going to just work on DB schools. So here is my item with search terms. It's just an item, which is a generic anything, and a list of search terms, which are just a bunch of strings. And then I've created a protocol to convert something into an item with search terms. And it just has one function, toItem with search terms, that converts it into an item with search terms of the particular type. Now this is going to come in handy right away because we're going to make DB school into an item with search terms convertible. So I'm going to go into database, make a new file, Swift file. This is going to be DB school plus item with search terms convertible. And this is going to be fairly straightforward. I'm just going to drop it in again. All that it's doing is converting each one of those individual search terms into an array. And they are going to be lowercase in that array. So it's building a grid. We're going to be doing kind of a grid search. One 1D array against another 1D array. So you can kind of start to imagine a 2D array. All right. Now let's introduce a new thing into search, and this is going to be generic as well. This is going to be called search helper. So I'm going to create a new file in search, a Swift file, and I'm going to call this search helper. And I'm going to drop in the skeleton for this too. It's going to have a generic search item as well. And the main function that this is going to have is eliminate shared matches with words and items. And these items are these items with search terms. So this is kind of our 2D comparison. Let's go ahead and give database manager a search helper. So in database manager, I'm going to say private let search helper equals a search helper of type dbSchool. Okie dokie. So let's pipeline our search school results through that search helper. And to do that, I'm going to rename result to CoreData result. And I'm going to then convert this into an array of item with search terms. So I'm going to say var items equals CoreData results.map, and this is going to be that dbSchool dot to item with search terms. And then I'm going to filter it down. So I'm going to say items equals await search helper dot process raw matches. The words are our search words, and the items is just items. Then for result, we've got to just get the dbSchool out of these item with search term array. So I'm going to say return items.map, and it's going to be the item.item, which is our dbSchool. So let's jump back to search helper and let's fill it in. Basically, process raw matches gets called. There's only one real function in this whole helper, which is just eliminate shared matches. And it just so happens that if the word count is less than or equal to 0, it's just going to return the items back. That's probably never going to happen. So I'm going to paste in more of eliminate shared matches and briefly explain this. I encourage you to grab the code and check it out and read through it if you have trouble understanding it. So what we're doing here, we're looping through each item, and we're going to decide if that item should be in our final result set or not. And to do that, we're going to call helper. Helper is a recursively defined function. Helper is going to perform brute force analysis. The helper is called for each item. For that item, it's basically going to check every word against every search term on the item. There's this array used search terms that's going to keep track of which search terms we are already matching to words so that we don't use them twice. We're testing literally every combination of word to search term. So there is no way we can be wrong as long as this is implemented correctly. So I'm going to drop in the whole body for helper now, and this is a mouthful. So there it is. So once again, this is recursively defined. You can see the exit cases. Once we have a match, which means match count is equal to the words count, that's a win. We return true. If word index spills past words counts, that means we didn't find a match in time. That's a loss. And the rest of it is basically just doing a loop. It isn't any kind of fancy backtracking or anything. It's just literally every search term for every word. All right, so I'm going to run that and check this Frank Sinatra example. So So if I get rid of school and I type Frank school, I still have 4. But then as I start typing it again, it wants to match that word school twice. And only Frank Sinatra School of the Arts High School has school twice. So this works. Okie dokie. That should be good for now for getting the result set. Now what we really want to do is sort that result set more properly, and we want to do this in a way that CoreData can't quite match. So I'm going to create a new group at the root level directory, and I'm going to call this bracket sort, close bracket, and within sort I'm going to make a new file, and this is going to be a node, specifically a sort helper node, and I'm going to drop this in. So sort helper node represents the sort ranking of an item with search terms. There are going to be 5 tiers of precedence for sorting. Tier 1 is prefix count. So if your search was BBT, B space T, then Big Bang Theory would rank higher than Bobcat because it matches 3 prefixes. Tier 2 is in order exactly. So if your search was Alice in Wonderland, then an item with Alice in Wonderland would outrank an item with Alice in Super Wonderland. Tier 3 is in order staggered. So if your search was Alice in Wonderland, then Alice in Super Wonderland would rank higher than Wonderland in Alice because the term ordering is congruent with the search input. Tier 4 is does it start with the same word? So if you searched for Alice in Wonderland, then Alice in Wonderland would rank higher than Space Alice in Wonderland. And finally, tier 5, which isn't defined in this file, is going to be the expected order or database order, and that'll just be the default ordering. It could be alphabetical in your example, but I think the default database ordering is a good one to go with. So I'm going to create another new file and call this sort helper. So sort helper, and again generic, and I'm just going to drop this in, and all that this function does is process search results and potentially reorder them. So this items with search terms, that's just going to be what comes out of our search helper. The preferred ordering we can get by just fetching the results from the database. And I build this preferred order dictionary, which is just the array index that each item appears at in the preferred ordering. And I'm just creating these sort helper nodes. I'm not doing anything with them yet. I'm just creating them. And then I'm just mapping them back to search items, which in our case is going to be DB schools. So let's go ahead and integrate this sort helper. So I'm going to go to Database Manager, and up here where I have search helper, I'm also going to make a private let sort helper equal a sort helper. Of course, it's going to be for DB school. And then in search schools, I would like to now pipe this items through sort helper. So I'm going to say let result equals await sort helper dot process search results. But we don't have this preferred ordering. So we're going to need to just get that, and we'll just get it by doing an extra fetch. So I'm going to say let preferred ordering equals try await fetch schools. And I'll stagger these. So the words are just going to be search words. This items with search terms are just items, and the preferred ordering is this preferred ordering. And now we can just return result. Okie dokie. So let's just go ahead and fill in this giant sort function on sort helper. So assuming that all of this stuff on the nodes is filled in correctly, we should just be able to run our prioritized sort like so. So all this is doing is first comparing prefix count. If they're equal, then we go in. If they're not equal, then we return essentially the one with the higher prefix count. And it goes inwards in that same order, going from prefix count to in order exact to in order staggered to does start with the same first word, and then finally to the ordering in the preferred order array, for which these indices are stored in that dictionary. So no real tricky thing here. It's just everything is typed exactly correct. So that is going to sort properly. But it isn't going to work until we fill everything in on sort helper node. So let's go to sort helper node. And how do we compute the prefix count? Well, we're going to use a function called compute prefix count. And it's just going to loop through the words, and then for each word it's going to see if that's a prefix to any one of the terms. If it is, it's going to increment the prefix count. So on init, I'm going to compute prefix count. And then priority 2, compute is in order exact. So if all the words are contained within the search terms in the exact order without any gaps in the search terms, then ultimately this is going to return true. And if at any point one of the words isn't contained in one of the search terms, then this is going to return, and is in order exact is going to be false. So I'm going to call that compute is in order exact. And then slightly trickier, the in order staggered. This is similar to is in order exact, except that it allows for gaps in term index. So this term index can run on ahead while the word index stays for a no matcher. But ultimately, it's not going to get set to true until the word index gets to the end of the words and everything has matched. So I'm going to go ahead and call that on init too. Compute is in order staggered. And finally, compute does start with same first word. This is just checking if the first word in words and the first term in search terms are exactly starting with the word as a prefix of the search term. So I'm just going to call that on init2. Compute does start with same first word. And now I'm going to run it and check out a few little examples. So you can see that when I search for school, now everything with school as the first word is showing up before anything with school as a later word. If I want to search for school for excellence, and I just start naturally typing that in, school for excellence, it's going to go to the top. And this is because of the sequencing rules and the first word rules. So if I want to switch the search to something like Bronx, and I want to do, I see Bronx Lab School, so I'd like to try to find that one. If I type Bronx LA, well, you can see that two results with Bronx and LA in the same early sequencing are matching with our early sequencing. So it ends up being a very good sorting algorithm for searching. You're welcome to change it, use it how you want, but I think it's great. Okie dokie. So now let's do the boldifying. I'm going to go to the UI group. I'm going to make a new file. And this is going to be a Swift file. I'll call this matching text boldifier. And I'm just going to create this matching text boldifier. And the way boldifier works is every time the search term updates, it has to be reset with these new search words. And from boldifier, ultimately, we want to get an attributed string. So I'm going to just add a function to it, attributed string for school. And this is just simply going to return a attributed string, which is equivalent to a regular string for the school's name, just as we link it up. So now on view model, first of all, I would like to get rid of school from the initial search text. So I'm just going to go ahead and do that really quick. But I want to add one of these boldifiers. So somewhere near the top, I'm just going to say private let boldifier equals a matching text boldifier. And whenever we update the schools, I want to reset the search terms on this boldifier. So right here where I do self.schools equals UI schools, I also want to do self.boldifier.reset with, and the words are just going to be our search words. And now I want name for school, instead of a string, to return an attributed string. And I now want to return boldifier.attributedString for school. So that means I've got to jump into school search view. And on school cell, instead of using a string, I've got to use an attributed string. I just like to run it and make sure it still works, that things still show up. Yeah, it looks like they do. Great. Alrighty, so let's put a knife in it. To get this attributed matching working properly, I want to add some pre-computed data. So on UI school, I want to create 2 character arrays which match school name, one of which is just a character array from school name, and one which is lowercase. So I'm going to say let school name char array be an array of character, and then I'm going to say let school name char array lowercase be an array of character. Now on this init, I'm just simply going to say self dot school name char array equals an array from school name, and self dot school name char array lowercase is an array from school name dot lowercase. Now I'm going to go back to matching text boldifier, and I'm just going to drop in this function matching character array. So here it comes. This is going to generate a Boolean array that has a true anywhere where there is an overlap between one of our words and that string array. And it just does it by looping through the whole entire string array and then looping through each word at each one of those indices. There's nothing smart going on here. It's just a brute force search again. And now, based on that matching array, I'm going to add another function to build a Markdown string. The way Markdown works is any part of the string that you want to be bold, you put star star before and after that. So this function just takes that matching array and that input string array and essentially inserts those star stars for us, including the very end too. Now I'm just going to modify the function AttributedString to factor in the uppercase or the mixed case and lowercase versions of the array. So we build the matching array with the lowercase array because we're doing lower to lower, so capital A matches little a. And then the Markdown string is being built with the mixed case array so that we display the same thing that we get back from the database to the user. So that's it. That's the end of it. Let's take a look at it. So if I type BRO, you can see that that part of each word is bold. If I type bro lab, you can see anything with lab or bro is boldened. So this will really razzle dazzle anybody and make your app shine, possibly getting to the #1 position. And that is a handsome paycheck. So pat yourself on the back, like, subscribe, share it with your friends, post it on an internet forum, steal it. I encourage you to steal it, sell it, take my name off of the file, do whatever you want. I can't stop you. Goodbye.